So this video is a continuation of Chapter 2 of Geometry. It's Section 2.3 and 2.4. Section 2.3 is really about differentiating and defining objects or groups. So again, definitions are going to be very important. A good definition places an object in a group of well-defined objects and then states how it differs. So, for example, if I were to define a pentagon, I would say a pentagon is a polygon with 5 sides. And then the converse is the reverse statement. The conditional is also called the if-then form, and it's done by putting your definition into an if-then form, such as if a polygon is a pentagon, then it has exactly 5 sides. And so the converse of this would be if a polygon has exactly 5 sides, then it is a pentagon. Another example is, we could say the conditional form, if 2 points are on the same line, then they are collinear. And the converse of that would be, if 2 points are collinear, then they are on the same line. So the biconditional is that you can combine a conditional statement with its converse, and that's also called an if and only if statement. And for example, you could say a polygon is a pentagon if and only if it has 5 sides. Or another example, 2 points are collinear if and only if they are on the same line. So to test your definition, you would try to find a figure that meets your criteria but isn't what you're trying to define, which would be a counter example. And if you can't find one, that means that your definition is good. So now we're gonna use this new knowledge while also defining some more vocabulary that you need to know. So a right angle. So I'm gonna give you some examples that are right angles. And then some examples that aren't right angles. So from this, we can see, and so for future reference, a note, these little squares in the corners means that this angle is going to be 90 degrees. So from this, if these are not right angles and these are, we can define a right angle as if an angle is 90 degrees, then it is a right angle. So we're going to do the same thing for acute angles. So this is an acute angle. And these are not acute angles. So these are not acute angles, but these are. So we can find the definition that if an angle measures less than 90 degrees, then it is an acute angle. And now we're going to do the same thing for obtuse angles, although the pattern may have become clear. So those two are obtuse angles, and these are not. So here we can say if an angle measures greater than 90 degrees, then it is an obtuse angle. Now, how I like to remember this is that since acute angles are smaller, I like to think of them as the cute angles, since cute things are sometimes small, like kittens or mice, I don't know. So now we're going to cover some more vocab. The midpoint of a segment. So this is, so if we could have a line segment here, then the midpoint of this segment is going to be the point that is in the middle of the line so that either side is congruent, or the same size. So what these little lines represent is that these segments are congruent. Angle bisectors are somewhat similar, so if we have an angle here, angle ABC again, then the angle bisector is going to be the line that intersects the vertex and splits up the angle into two congruent smaller angles, two halves. And again, these lines represent that they're going to be the same. Okay, so section 2.4 is just more vocab. So we have parallel lines, which are going to be lines in the same plane that never intersect. So they never cross each other. Perpendicular lines are also lines in the same plane, but they intersect at a right angle, so a 90-degree angle. So again, same plane, but they intersect at a 90-degree angle. Complementary angles are angles which, two angles whose measures add up to 90 degrees. So if we have a right angle, then the two angles within it would add up. Or if we have two angles, and say one of them is 70 degrees and the other is 20, then they would be complementary as well. Supplementary angles are very similar. They're again a pair of angles whose measures add up to 180 degrees, which means they look something like this. Or we could have them separated and say this one is 120 degrees, then this one would be 60 degrees. Vertical angles are angles if we have two lines intersecting each other like this, then vertical angles are the pairs opposite each other. So say this is angle A and this is angle B, then angle A and angle B are vertical angles, while if this is angle C and this is angle D, then they're vertical here. So a linear pair of angles is similar to supplementary angles, except that they have to be on the same line and they have to share a side. So this works, but this does not work, even if they add up to 180. So no, yes, yes. They are on the same line, meaning that they would also be supplementary and share a side. And that is all the vocab in these two sections.